Hey guys, here's a video to help you with the derivative stuff. So the first thing is going to be what we call like exponent rules or the standard derivative stuff. So you'll probably get a polynomial. I'm just going to make something up. 10x to the third minus 2x to the fifth plus 7x minus 11 plus the square root of x, let's say. So in this situation, because of the plus or minuses, you separate each one to their own individual derivative. So the derivative here is always going to be the power moved down, and then you reduce the power by 1. So 3 times 10 is going to be 30. X, and what's left over is to the second power. Same thing here. Bring it down. Negative 5 times 2 is 10. X to the fourth. Here, this is a visible 1, so if you move that down, it's going to become 7. And then it's x to the 0. Since it's x to the 0, it doesn't show up. For this one, you either know that constants always become 0, or you imagine it's x to the 0 power that you're bringing to the front, which means x to the 0 power will multiply the whole thing by 0, so that doesn't show up. And this one, you need to rewrite. So square root of x is going to be rewritten as x to the half power. Once you rewrite it as an exponent, you can work with it. So bring down the half power. So it'll be 1/2. And then what's going to be x to the negative a half. But it's a negative half power. A negative exponent is going to move to the bottom. And it's going to be a square root of x. Just a reminder, because I think some people might have forgot. Let's say this is n, and this is x to the m. That's the same thing as x m over n. So anything in the root will become the denominator, and not on the root. So whether m is here or outside will be the numerator. So know how to change the roots into square roots, the roots into exponents. Next one, I'll probably give like a complicated one, something like let's do like a square root of x over x. So here I might ask you to derive this. We'll find f prime. So that means I'm going to rewrite this as x to 1/2 over x 1, which means when you subtract, when you have a division, you subtract. So this x to the negative half power, which I could turn into 1 over square root of x. But remember, I'm going to derive it. So now I'm deriving. So I'm going to bring the negative a half in front. And then x, I'm going to subtract a 1 over 1, but I need a common denominator, so it's going to be a 2 over 2. So it's going to be negative 3 over 2. But I don't like negative square root or negative roots. So negative 1 over 2, the square root of x to the third power. I could put the third inside, outside the square root, or inside over here. Doesn't really matter. Like that could be done. The next one is quotient rule and product rule. So let's do the product rule. Remember, it's going to be two functions, f times g. That means it's going to be fg prime plus gf prime. So because it's going to be those things, what we're going to do instead is, if we have something like this, let's say it's e to the x, x to the 10th, let's say. Well, if this one's f and this one's g, it might be easier to kind of think about it. By the way, know this equation, or there's multiple ways to write the equation. So it's maybe good for you guys, if you want to, is to write it as separate. Here's f, and here's f prime, and here's g, and here's g prime. So sometimes writing them separately and then plugging them later will make it a little easier. So f is e to the x, f prime is e to the x. Remember, e to the x has a special property that it's recursive. G is going to be x to the 10. G prime is 10 x to the 9th power. With that in mind, we're going to rewrite this. So f, which is e to the x, times g prime, which is 10x to the 9th, plus g, which is x to the 10, f prime. So that's e to the x. Okay, and I'm just going to rewrite it so it's a little bit neater. 10x9 e to the x plus x10 e to the x. So e to the x makes it kind of easy to derive. So that's pretty useful. Now you could have something like this. Let's do x to the 3rd. Let's do like 3x squared plus 2x, let's say. So in this situation, you have two ways to do it. You could do the method I just said. The product rule, f times g equals f g prime plus g f prime. Which means f, this would be f and this would be g. So f and f prime, g and g prime. So f is x to the 3rd. F prime is 3x squared. G is 3x squared plus 2x. G prime is going to be 6x plus 2. Then we do the product rule. So f times g, so x cubed times g, which is g prime, which is 6x plus 2, plus g, which is 3x squared plus 2x, times f prime, 3x squared. Distribute the x cubed to everything. 6x to the 4th plus 2x cubed. Here, distribute this 3x squared to everything. 9x to the 4th plus 2x to the 3rd. Yep, to the 4th, my bad. No, to the 3rd, that's right. And then, combining in like terms, so 6x to the 4th, 9x to the 4th, 15x to the 4th, plus 2x to the 3rd, plus, oh, and then these combine actually, my fault. So that's going to be 4x to the 3rd. Now it's very useful because, hey, we got the answer. But I could imagine for you guys, you would like an easier way to do this one. The previous one, we couldn't do this shortcut way I'm about to show you because the previous one, let me see. The previous one, ex and x to the 10 cannot combine into one term. But here, before I started, what I could actually do, so this is like an alternate route. Let's just do x cubed, 3x squared plus 2x. What I could do is take these numbers and just distribute first. So x cubed, 3x squared, will be 3x to the 5th, plus 2x cubed plus 2x is 2x to the 4th. And then I derive each one. So I'm going to derive. So that's going to be 15x to the 4th plus 2 times 4, 8. Did I make a mistake somewhere? I did make a mistake. This should be a 6. So this should be a 6. So this would be an 8. So that should be 2 to the 4th, 8x to the 3rd. If you notice, assuming you did both correctly, unlike I did, you should get the same answer, no matter which method you use. I'm partial to the purple one, but it's not always that the purple one's available. Again, if you have like an e to the x, or if you have like a trigonometry one or something like that, you could not do it. Please don't sweat. There's no trigonometry on this test. But here, we're able to do. Where we could FOIL it first to make it simpler, and then FOIL, or factor afterwards, or derive afterwards, my fault. All right. Now I don't want to make the mistake of doing the wrong equations. Oh, not quadratic, quotient. Oops. I don't want to make the wrong equation. All right. So for this one, we're going to do f over g. So when we have a division, and the rule is, and I have to check this because I don't want to make a mistake here on the video at least, g f prime minus f g prime, so I guess you could think of it as the bottom should go first, over g squared. So here's an example of that problem. We're going to use this equation. So let's say if I gave you 3x squared minus 10 over 2x plus 4. Here, if you could factor and simplify, you could, or you should. In this case, there's no way I could factor the top and the bottom to make anything remove. So instead, now I have to derive using this quotient rule over here, f and g. So that means I'm going to follow along. Sometimes it's easier to label it first before you move on. And getting that used to labeling is useful just because when we get more complicated formulas, it's good just to label. So f is going to be 3x squared minus 10. F prime is going to be 6x. That's it. G is 2x plus 4. G prime is just 2. With that in mind, let's just plug it in. G goes first, so that's 2x plus 4 times f prime, which is 6x, minus, I usually use brackets to represent this as the whole thing itself, f 3x squared minus 10, g prime 2, all over 2x plus 4. From here, we take the 2x, 6x, we're going to multiply it to the 2x, and we're going to multiply it to the 4. In here, I'm probably going to distribute the 2 to the 3x squared, and the negative 10. So I'm going to get 12x squared plus 24x minus 6x squared minus 20 over 2x plus 4 squared. All right, you subtract when you can. Let's see. I have a common denominator or a common factor here. So 12x squared minus 6x squared is 6x squared. Positive 24 has no matching match, so positive 24x. And then negative 20, it's behind a minus sign, so make sure you write it as plus 20. Over 2x plus 4 squared. It's very important. You do not need to FOIL out the bottom. This is already a factor. It's technically 2x plus 4, 2x plus 4. Now, from here, I'm going to tell you you're done with your work. You could technically simplify farther, where you take out a 2 on the top, you could take out a 2 on the bottom, and simplify more. But I'm not going to make you do something like that. We're going to stop right here, okay? So we did the questions, word problems today. We're not going to have that on our quizzes. We'll have that pop up on our tests. The purpose of the quizzes is to help you get used to get used to the formulas. And I'm telling you, these formulas, you just have to practice remembering and using. And the more you use it, the more you remember. Even to the fact that I don't remember it unless I practice it. So it's going to take me a couple of days to remember this, or it will take me like a day to remember this. I expect you need to study to make sure you remember this. I'll post some extra work from the textbook. I can't find any good worksheets for this, so I'll post some extra questions from the textbook. Hopefully that helps with the solution manual. All right, good luck on your quiz on Wednesday.